Hey, it's Mr. Allred here, and we've been talking about the transformations of graphs, and we've gone through 4 of the things that are important. So, one, we talked about how we could reflect something across the x-axis, reflect something across the y-axis, move something up or down, move something left or right. So the last thing I want to go through is if we put a multiplier in front of the function. So let's see what a good function would be here, and that might be the absolute value function, so absolute value of x. And keep in mind that that meant when we plug in an x, we get the positive value for y. So negative 2 gives us a positive 2, negative 1 gives us a positive 1, so on. And that was our V shape. Okay. Nice V shape absolute value graph. So what I want to do here is look at what happens if I put something like a 2 in front of that absolute value. Well, just like putting a negative in front of there, it changes the values I already get. So let's imagine we're putting in the same numbers, negative 2, negative 1, 0, 1, 2 for x. But when I plug in negative 2, the absolute value is positive 2, but then I'm going to multiply it by 2, so I get 4. So basically I doubled the old output at negative 2. If I plug in negative 1, I get 1 multiplied by 2. The old output was 1, the new output is 2. So I can go down and calculate the rest of these, but I am really just, let's move my face over, I am really just doubling the output from the regular absolute value function. Well, let's see what it looks like. First of all, when I plug in 1, now I get 2. When I plug in 2, I get 4. And there's different words used to describe this. What I usually say is it stretches vertically, and that is if the number we have there, the absolute value of it, is greater than 1. So when I say the absolute value greater than 1, that means if it was a negative 2, not only would it stretch it, but it would also flip it over. But the fact that it's a number bigger than 1 or less than negative 1 means it's going to kind of close that up around the y-axis. The comparison of that would be, what if I use something less than 1? I could use 1/2 the absolute value of x. Well, basically that's taking all the original absolute value outputs and cutting them in half. So when I plug in negative 2, the absolute value turns to positive 2, but half of that would be 1. So if we take all the old values, we will be cutting them in half. Of course, half of 0 is still 0. So what does that do? That causes this thing to kind of open up, if you look at it that way. But the wording I use is compress vertically. And that's if that multiplier is less than 1, the absolute value. So between negative 1 and positive 1, it would kind of smash it. Now, depending on the orientation you look at there, compress and stretch might mean different things. So if you look at the x-axis, that's one thing. And if you look at the y-axis, that's another. Okay. So we went through the 5 things that I want to be looking for, and we went through the parent graph. So just to make sure everyone's aware, I'm going to go back to, figure out where I'm going back to here. Here, I believe. Not there. Where are we? I'm a little lost now. Oh, I know where I'm going. I'm going here. And let me make this a little bit bigger if I can, or at least move it. So remember the parent function listing that we had. So you have those graphs to reference back to, and in that same file, if you continue on to the second page without all the slideshow and graphs there, here is the information that I was producing in the last two videos, where what happens if we add a number to the end or throw a negative in there. So it's summarized on the second page of the parent function graph file. So make sure you know where that is in case it's a lot of writing or you need a quick reference. Okay, we're going to do some examples in the next video.